So today we're going to be evaluating logarithms. So if we look at this first example, we got log base 3 of 27. We have no idea what log base 3 of 27 is. So let's just say it's equal to question mark since we don't know what it is. And now what we're going to do is we're going to try to get it into a form that we know how to work with. In the last chapter, we've been working with exponents. So remember, we're going to start with our base here. We're going to do the circle of life. So we're going to do 3 to what power is 27? So I just went 3 to what power is 27? So now, let's think about 3. 3 to the first power is 3. So it's not 3 to the first power. 3 to the second power is 9. 3 to the third power is 27. So my question mark would be 3. So the log base 3 of 27, the answer is 3. So this is how you want to think when you're solving these logarithms. So if we try this next one, let's do the circle of life. So think of there being a question mark here. I'm just going to erase it. But think of there's a question mark there. So you start with your base. So you're going to ask yourself, 5 to what power is 625? Well, we can go off to the little side here. 5 to the first power is 5. 5 to the second power is 25. 5 to the third power is 125. 5 to the fourth power is 625. So what's log base 5 of 625? The answer would be 4. 5 to the fourth power is 625. All right, so those were easy. Those are some of the easy ones. Those are the ones that you definitely should be able to do in your head. Then we get to this next one. There's a little trick you gotta do on this one, but you're gonna do it the same way. So think of it being as a question mark. So you're gonna go 3 to what power is 1 over 9? Okay? So we got this one going. I'm just gonna oops. Let me erase this over here so I can write over here. We're trying to figure out, you got to raise 3 to some power to get 1 over 9. Well, 3 to the first power is 3. 3 to the second power is 9. These numbers over here are getting bigger. I want them to get smaller, so I'm going to have to go backwards. Well, 3 to the 0 power, remember, is 1. Okay? But remember, we have a rule that says if you have a to the negative n power, if you have a negative exponent, what that does is that turns your power into a fraction. It makes it 1 over a to the n power. So right here, we got 3 to the second is 9. What would happen if I made the 2 negative? Well, what is 3 to the negative second power? Well, if we use this rule up here, that says it's 1 over 3 squared. 1 over 3 squared is 1 over 9. So log base 3 of 1/9 is negative 2. So most of the time, when you have a problem like that third one, when you have a whole number here and a fraction over here, to make it match, you're probably going to have to use a negative exponent. Okay? So let's look at these last 3 examples. All right, if I can get them down there. My computer is giving me a little bit of trouble here. All right, we want to know what's log base 8 of 8. Again, let's try to do this in our head if we can. So we're going to do the circle of life. We're going to ask ourselves, 8 to what power is 8? This should be an easy one. How do you get 8 to be 8? Well, 8 to the first power is 8. So log base 8 of 8 is equal to 1. All right, let's try the next one. Log base 25 of 5. Well, we'll do it again. 25 to what power is 5? 5 to the first is 5. 5 to the second is 25, right? 5 to the third is 125. These numbers are just getting bigger and bigger and bigger. I want, oops, no, I shouldn't have did 5. I should have did 25. So let's look at 25, sorry. 25 to the first power is 25. 25 to the second power is 625. Now, still these numbers are getting bigger. So that means my exponent on my 25 on the top up there for the question mark should be smaller than 1. So most likely it's going to be a fraction. Now, if you remember back when we had a rule that says if you have a fractional exponent, so if you have a to the m over n power, well, remember you can rewrite that as the nth root of a to the m power. All right, so on this example up here, we got 25 is equal to 5. If I put 25 under a radical symbol, what radical of 25 is 5? Well, remember the different types of radicals we have. We got square roots, cube roots, fourth roots, fifth roots, and so forth. Well, the square root of 25 is 5, right? But remember, when we talk about square roots, because it's the most common radical that we use, we don't write a 2 there, but there's really a 2 there. And then there's a 1 here. So the square root of 25 could be rewrote as 25 to the 1/2 power. These are the same thing. One's written as a radical form, the other is written in exponential form. 25 to the 1/2 power is the same as the square root of 5. So we go back up here. The log base 25 of 5 would be 1/2. And again, we're using this rule right here. So let's look at that last example. That last example is similar to the example we just did. We got 27. So we're going to ask ourselves, 27 to what power is 3? Well, anytime this number over here is bigger than this number, most likely you're going to have to use a radical. So let's put 27 under a radical and go through the different ones. What's the square root of 27? Is the square root of 27 3? No. So it's not the square root. What about the cube root? What's the cube root of 27? That's 3. So how can I rewrite this right here as a power? Well, it's going to be 27, and then we got a 1 here, so 1 over your index, which is 3. So the log base 27 of 3 is actually 1/3. So there's a few things that you want to notice. Some of the things that's going to come in handy. When this number right here is bigger than this number, you're probably going to have a fraction. Okay? When you have a whole number here and a fraction here, that means you're probably going to have a negative involved. Okay? Those are some things you want to remember when working on this assignment today.